I'm going to talk through the rubric for MSL IA. It's divided into several parts. Each part is part of the 20 points. I think there's like 5 sections. So A is communication. That sounds pretty obvious, but we'll talk about how that's different than B, mathematical presentation. C, personal engagement. That seems kind of hard to measure, but we'll talk about how they measure that. D is reflection, which of course is really important in our class and really important in the IB. And finally, E, use of mathematics, which is the most obvious part of it and the part that counts the most. So let's start at the beginning. I've highlighted some important words in each section to remind me of what I should talk about. Let's start at the top, and the first thing I highlighted was about the level of the course, the syllabus, and whether or not you should write about things that are in the syllabus or outside. I would try to stick within the syllabus. If you choose concepts from the syllabus, you will probably be writing at the correct level of difficulty of the math, not too hard, not too easy. It might seem like, oh, if I do something really hard, I'll score better. But the danger is you do something kind of hard that's outside the course, who's to say that you really understand it? And you'll kind of betray that lack of understanding in your explanation. It's pretty hard to fake the math teachers out in terms of your understanding. So try to choose something inside the syllabus, although if you choose something that is about the same level outside the syllabus, that would be fine too. Second paragraph. So it says teachers and students must discuss the exploration. If your IA is going to come out good, you'll probably be talking to me several times throughout the process. Not all at the end, not all at the beginning. Like along the way, you should be talking to me once a week, once every 2 weeks, always to keep on track. Of course, if you don't do anything in between the 2 times you talk to me, the conversation will be a repeat of the previous one. So make sure you do 1 or 2 things to progress before you come talk to me again, right? The report should be 6 to 12 pages long. That's not including like cover page, not including bibliography. We can talk about if you're starting to go over that, but there's really no reason for a Math SL IA or even an HL IA for that matter to go over 12 pages. If you're going over 12 pages, it means you have written enough and you're probably writing too much. What do I mean by writing too much? You're giving yourself more opportunities to make some huge mistake, which is going to make your IA worse. So try to keep it less than 12 pages. Explaining your work is super important. That's what makes people believe that you really understand what you did, which is the main purpose of it. Okay, so like whenever you do any kind of math step, you need to convince me and whoever else reads it that you know what you're doing. And we do that through an explanation. The explanation should be given at the level that your peers would understand. So I would say a peer, so 11th grade, 12th grade student who doesn't necessarily know the math concept you are using. So you should be explaining the math concept to someone who is about the same level in math as you are, but who doesn't happen to have learned that concept. You will have sources. I'm not saying you should be writing a history of anything, but in the process of doing your data collection and figuring out how to process your data, you definitely will have a couple things to write down as sources. Your math method also. It might, one of your sources might even be your math book. In the communication section, so really important to explain why this topic is special to you. You should have different math representations like graphs, tables, and diagrams. positioned in the appropriate place. So like they should be like interspersed throughout the text. Shouldn't be all at the end in the appendix. Every time you refer to a table or diagram, it should be right there in the text. You should have finished the IA. Incomplete IAs score very badly. Whatever your objective was, you should have done it all the way to the objective. If you didn't accomplish your objective, then and the reason why was because it was impossible, you should rewrite it so that you have a different objective which was accomplished. Concise. So that means that a lot of times the math calculations can be repetitive. Make sure that you only show one of the iterations in your text, and then all the others you can throw in the appendix and say, hey, go look at the appendix if you want to see every single one of the calculations, but only the first one is included here. You don't have to have little titles breaking the thing up into sections. If you want, you can, but if you don't want to, that's perfectly fine too. Organization, coherence, the difference between the two, although they're both evaluated in this section, organization is referring to the structure of the whole paper, and coherence is referring to in between each section, how well do they link with each other, how well do they flow from one to the other. You remember how I said that your math, your tables, your figures, your formulas, everything should be right when you're talking about it, so your text should be in between the math. So you should have text, then you should have math, then you should have text, and you should have math. B, mathematical presentation. So what's the difference between communication and mathematical presentation? Whenever you're talking specifically about math knowledge, then usually that's going to be evaluated in math presentation. So like math terms, math notation, math symbols used correctly or not used correctly should be evaluated here. I said that the formulas, diagrams, tables, charts should be positioned in the correct place for criteria A. So criteria A, you'd take off if they were all thrown in the appendix or are not positioned well, but if the student did a bad job on formula, diagrams, tables, or charts, that would be taken off in math presentation, not in communication. Use of technology should be appropriate to provide the best possible display of your data, etc. Definitions and terminology here and not in section A. And remember that there's a certain kind of notation, which is like calculated notation, for example, the scientific notation that's calculated with E, for example. You should not write in your paper that same notation. You should write in textbook notation or handwritten notation. But if you do include some piece of the calculator output or computer output, then it's normal if there is a couple lines where it has calculator or computer notation. Personal engagement, part C. This is something that is, I don't know if I'd say it's the easiest to score on, but it doesn't require like good math execution to necessarily score well on this. Personal engagement means, first of all, that you chose something that you were really interested in, because that enables you to do things that they say here, such as make it your own. What does that mean? You're going to bring your expertise in the topic into the report, and the reader is going to see that you thought of something that other people wouldn't think, which is what they mean by independently and creatively. And applying math ideas in your own way. So that's impossible to do if you are not an expert or really enthusiastic about the subject. D, reflection. So reflection should occur throughout the exploration for a really good IA, not just at the end. Okay, so if you're just doing reflection at the end, probably your IA is not that good of a one. how do you do reflection throughout the IA? Well, the thing is, IAs usually don't all go according to plan, and during the IA process, you should actually talk about how, like, okay, phase 1 ended, I got this result, I needed to make an adjustment because there was a result that was unexpected, etc. So, like, after each phase, you might be making, like, small adjustments in your plan, and that should show up in your writing, and then that would make your personal engagements or your reflection score go up, because it's obvious that not only did you evaluate the whole thing, but periodically you were evaluating what you did up until that point and made adjustments, right? E, use of mathematics. That's the most obvious part. It's worth 6 out of 20, which is the heaviest score. You don't have to do a whole bunch of math processes or concepts to do a good job. If you do one super well, that is enough. It's not like studies where they require, like, 1 further math processes and 2 simple math processes. 1 really good math process is fine. The thing is, with MathSL, it's pretty hard just to have 1 math process, because in the process of doing your main process, usually you do 1 or 2 others also. So don't need to really worry about having enough math processes. Naturally, your final version is going to have probably more than 1, even though you don't need more than that. Finally, it's super important for you to show that you understand what you're doing. And so not only is that explaining how each math process was executed, it's also important to explain why each math process was chosen, because that's part of understanding, right? What is it about that problem which necessitated using that particular math process, or why was it appropriate in that case? That's part of showing understanding, right? And that's it for the rubric.